All right, here we go. We're back. The reset has happened. So while we were resetting, you were supposed to be writing your possible equation to represent the given function. Okay. In order to do that, you have to pay attention to some very key important things. Key things that you need to pay attention to is that there's a hole, right? So looking at this function, I know that I have a hole. And my hole is at x equals what? X equals 4. So I have a hole at x equals 4. The other thing that I have to pay attention to is I have a vertical asymptote, right? A VA at x equals 2. I have a horizontal asymptote at what? Y equals 1. And I have an x-intercept, a 0 at what? Where is my 0 at? -3. Okay, so these are the 4 things that I have to make sure is true. Yes. Oh, yeah. I didn't know you wanted me to finish my sentence or not. It's cool. I love the excitement.
Plus 3 over x minus 4 x minus 2. Wrong.
What? All right. So we had in the numerator, repeat again, August. X minus 4. X plus 3. X minus 4. And x minus 2. Does this satisfy everything that we need at the top? Does this put a hole at 4? Yes. Does it give me a vertical asymptote at 2?
That's a be quiet.
Does it give me a 0 at -3? And does it make my horizontal asymptote 1? So for the normal people in the class that are supporting what we're doing, not Hudson today, how do we do? Good? All right, perfect. Moving on.
Mother of God, nerd. Oh, wait, you go back for a second.
No. All right, so here we go. So here we're going to keep going. We're going to talk about just general factoring and paying attention to the values in the numerator and the denominator. In this case, we are looking at our ability to just remember how to factor. If anything cancels out, pay attention to the holes. Yeah, talking about horizontal, vertical asymptote. Really quick, it's just as many variations of the same thing because you guys will be quick to say, you never did a problem with that in notes. I never saw that in our notes. We didn't do that. Yeah, it's called really exactly. We didn't go over that. So looking up here, what do I need to do before I get started? Factor. What am I factoring out? An x because that's the GCF, right? So I factor out the GCF and I'm left with x squared plus 2 over x squared times x minus 3. Okay. What happens here? X cancels out, but there's still 1 left in the bottom. So did it create a hole? No, because x cancels out and it's still 1 left in the bottom. It did not create a hole. It would still be a vertical asymptote.
Wait, what?
Because there's still an x in the denominator.
Oh, so we keep that x.
So therefore, at x equals 0, there is a vertical asymptote instead of a hole. Okay? And there would be no hole because even though it eliminated, there is still a value that is left in the denominator. Does that make sense? There we go. And then we have another vertical asymptote at x equals 3. And why is that? It's still in the denominator, right?
Is there a 0 What number? We loaded? Oh, yeah.
Okay, is there a 0?
X equals the square root of negative, of square root of 2.
It'll be a -2. Can you take the square root of -2? So is there an x-intercept? It's imaginary. So that tells us that there's
There's no 0.
no 0. So there's no x-intercepts. We're not doing it. We're just saying no. Because there's values where there's no x-intercepts. What else do we know about this function? And where other kind of asymptote is there? Where's the horizontal at?
Oh.
Go back to the original. So going back to the original, the degree of the numerator is 3. The degree of the denominator is also 3. Yes, it is. What's x squared times x? Ah, at y equals 1. Okay, so that's a full analysis of that problem. Yes? All right, your turn. Do it on g of x. I'm not listening to you. Yes, stating as much as you can from what's given.
On this, I'll be that there's no factor in that. Already.
Everything's already factored for you.
Welcome next.
You're analyzing it. You're telling me everything you can about it.
You have a hole in 0 at the same point
How do you have a whole and a 0 at the same point?
because two x plus 3 cancel out and we're left with 1 on the numerator.
It's considered a whole. So is it a whole or 0? It's just.
I'm asking.
That's a whole.
Hole, so there's no 0 there. But even though there's an x plus 3 left in the numerator.
It's gonna be a whole. Emiliano's right.
Thank you, Emiliano. You're very helpful. How's Gerardo Lumber?
Yes.
He's alive.
Good. I'd love to hear that. Great.
It's the horizontal.
Mhm.
Is it always the original?
It's always the original. Yep. Ready?
What's the numerator, degree is bigger than the denominator degree?
There's no horizontal.
Those.
Hmm?
If there's repeating repeating
Factor?
yeah.
Mhm.
Does that mean there's no hole?
No.
Why are you doing Kahoot?
Look at.
I'm not doing anything. What are you talking about, man? What are you talking about?
All right, come on, we gotta go on. So here we go. So far from here, you notice that the x plus 3 eliminated, right? But it only eliminated in the denominator. So you're still left with x plus 3, and you were left with x minus 2 in the numerator, and you were left with x plus 1 in the denominator. Agreed? All right, so from here, we know that we have a vertical asymptote at what? X equals -1, right? The second thing you easily notice is that you have a 0 at x equals 2. And then what happens at 3? -3. It's a whole. At x equals -3, there is a whole. Okay. And it's a whole this time because it stayed in the numerator. Does that make sense? On the last one, we had double factors, but one was left in the denominator, and that created a vertical asymptote. This time, we had the double factor, and it was left in the numerator, so it's going to create a whole. Okay, what about horizontal asymptote? Listen, there's no horizontal asymptote.
Oh, yeah, right. There's a oblique.
It is an oblique. There's no horizontal asymptote. And the reason why there's no horizontal asymptote is because the degree of the numerator is greater than the degree of the denominator. Okay? Yes. All right. So in conclusion, things that we need to summarize about this is based on the powers of the factors. So we're analyzing the powers of the factors. If you have equal powers on the factors, meaning that everything eliminates in the numerator and the denominator for that factor, that's when you're going to have a big old whole. Okay? If the power of the factors, so if the power of factor is larger and the numerator, you're also going to have a whole, which is what example B was telling you. So looking at B. And then therefore, if the power of the factor is larger and the denominator, we're going to have a what? That's where we have our, if you go back and look at example A, there was a vertical asymptote. So that will be our example A, shows us that there's a vertical asymptote. Your no horizontal depends on the degrees of the.
Yeah.
Okay. Diving a little deeper into rational, reiterating this, is it solidifying some things that you may have not fully grasped the first time? Yes. Okay. Next, we're gonna review long division, and that's because we're gonna start talking about oblique and slash slant asymptotes. Is he joking right now? He's joking right now. You better be joking right now. You better be joking right now.
I like it.
I never knew that. Never. Based on our test scores? I don't know. I don't know if you were there, but yeah. Kind of like it was necessary.
Yeah, we did. It's that coming out actually.
All right, here we go. So, y'all asked for it. I was honest. This is why we're doing what we're doing. Okay. Yeah, we just can't let it. Oh, they did bad on the test. We're just gonna move on. No, can't do that. So, here we are, relearning things.
Yay.
Yay! So exciting. All right, division algorithm. So remembering how to divide. All right. So for division, we have our different parts. You have your quotient, divisor, dividend, and remainder. Do these words ring bells? Yeah. All right. Our quotient, our divisor, and our dividend are all the parts. What's your quotient? Your quotient is your answer. The answer to a division problem is called the quotient. The answer to a multiplication problem is called the product. There we go. All right, we're going to take this slow. We're going to start with 4th grade math. Okay? Yeah, we are. I know.
No, I need it. Yeah,
We're going to start with 4th grade math. So we have 675 divided by 21. All right. We're going to set this up and perform long division. Are you with me? If you remember how to long divide, work ahead. If not, please make sure you're paying attention and following along. So we have 675 goes in the house. 21 goes outside. Yes. So we ask ourselves, can 6 be divided by 21? Self says no, not going to work. Okay. Then we ask ourselves, can 67 be divided by 21? Myself says yes, it can. 67 can be divided into 21 with 3 times. So now I'm going to multiply. 21 times 3 gives me 63. Yes?
Oh yeah.
Oh, yeah. Yeah. Okay, now we're going to subtract because after we divide, we multiply, we subtract. 67 minus 63 gives me a remainder of 4. Yes? We're good? We're still here?
Oh my God. Kind of hard.
You said refresh. I didn't think it was gonna go this back.
Yeah, uh-huh. Is that serious? Then we're going to bring down and repeat again. All right? 45. How many times is 21 going to 45? Twice. And then we multiply. 2 times 21 gives us 2 times 21 gives us 42. And then we subtract and we get 3. So we have a remainder of 3. Our quotient is 32. Our remainder is 3. So our answer is 32, 3 out of 21. That's it. That's the answer. You're done. What is tripping?
No one remembers this. Like I
don't know.
sat there for like 5 minutes on that question. I was like,
Wait, there's a question like
I could not remember this.
It was with polynomials.
Oh my god, I was stupid.
All right. Do we remember elementary long division? Do we see how we did that? Yeah. So it's your quotient and then and your remainder. Okay. Your remainder is written as a fraction out of what you had. Okay. If you were approximating, that's where you add the decimal and add zeros and keep going. Ringing some bells happening. Okay. Why are you doing that? We're writing it as a fraction and moving on. All right. This video is dedicated to Hudson and his weird child tantrum today. Yes. All right. Now, we're going to now apply this to what we're actually learning. We're going to now come to high school. Okay. Bye-bye 4th grade. Hello, high school. No. So, no. So here is the high school part that we need to be able to do. It follows the same process of divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Same process, okay? So again, this is my dividend. It's going to go inside the house. So we have 6x squared plus 7x plus 5. Okay, then our divisor goes on the outside, 2x plus 1. Stay together. We did do this in algebra 2. It's crazy. It's crazy. I know. Here we go. So again, we're going to start off. It's all based off of your leading terms, okay? 6x squared divided by 2x is what? 3x. Yes? We agree? 6 divided by 2 is? X squared divided by x is? So 6x squared divided by 2x is 3x. This is actually helpful for you. I know, it's crazy. All right, now we multiply. We're going to multiply your quotient times each part of your divisor. 3x times 2x is 6x squared. 3x times 1 is 3x. Yes? Just like we multiplied 21 times 3 and got 63. Yeah, same thing. 3x times 2x plus 1. Now we're going to subtract because there are multiple terms of subtraction. You're not just going to subtract the first term. You're going to also subtract the second term. And what happens here? Which is good. And we're left with 7 plus -3 is 4x. So we divide, multiply, subtract. Now we're going to bring down and do it again. So we're going to do it again. What is 4x divided by 2x? Say that again. 2. Thank you. All right. Now we're going to multiply. What is 2 times 2x? 2 times 2x. 2 times 1. 2. After we multiply, we then are going to, and you subtract all of the terms. Yes? And we get a remainder of 3. So our quotient is 3x plus 2. Our remainder is 3. So therefore, our final answer would be 3x plus 2 plus 3 out of 2x plus 1.
So high.
Oh, I remember this question, though.
I'm so happy for her. That's great. Yes? I didn't set it up for that. All right. How do we feel? Yes? No, you could just go to Google and type in polynomial long division practice. You'll get plenty. All right. Yes? All right. Moving on, because I don't like to do so much review. We still need to get to the real part of the student section, right? No, we're reviewing things. All right. So, do we need more practice?
No, like seriously, we should move on.
Are you sure?
Yeah.
Oh,
Nick,
this
all of
would
a
be
sudden,
great.
working at McDonald's sounded really good.
We do need to do it. Are we okay? Okay. All right. So we're gonna do this really quickly. I'm gonna factor fairly quickly. Is that okay? All right. So in the numerator, I'm gonna take out my GCF, and I'm gonna be left with x times x squared plus 3x minus 10. Correct? And that's gonna factor down to be what? X times x plus 5 times x minus 2. All I did was factor. Okay? I'm going to now factor my denominator, and my denominator is going to become x plus 3 and x plus 5. Agreed? So this is my factored form of g of x. From here, I can easily tell you what I have, correct? I have a vertical asymptote at what? Where is my vertical asymptote? At x equals -3. Do I have a horizontal asymptote?
Wait, is it
I do not have a horizontal asymptote. Why do I not have a horizontal asymptote? The degree of the numerator is greater than the degree of the denominator. So there is no HA. You have to go back to the original. Okay? But however, that means that I'm going to have a what? Slant. Your slant, you want to use the simplified form. You can work the original, but why would you want to work larger numbers? Okay? When you're finding your slant, you want to use the simplified. How do you spell simplify? Just gonna put a Y. Simplify. All right. So I'm gonna simplify this. Is that cool? I'm gonna take out the whole, and I'm gonna be left with x times x minus 2 over x plus 3. Which means that for the division problem, we have x squared plus minus 2. Sorry, I did. Plus -2 minus 2x plus 0 over x plus 3. Can I divide that? Yes, we can. So to find our slant, Your x plus 3 is your divisor, goes on the outside. X squared minus 2x plus 0 is your dividend. Could you have did this using the original? Yeah, but look how many more numbers and variables. Is it necessary? Use the simplified form. All right, x squared divided by x. X times x plus 3. After I divide, I multiply, then I subtract. Cancels, and I'm left with negative 5x plus 0. Do it again. Negative 5x divided by x is negative 5. Okay, then you have negative 5x minus 15. Flip the signs, and you're left with a remainder of 15. This is your remainder. This is your slant asymptote. So my slant is at y equals x minus 5.
Whoa.
Y is the what? Because you subtract. Remember, we divide, multiply, subtract. Divide, multiply, subtract.
Positive because it's
When it was a negative, yep, and I subtracted it.
So 15's the remainder.
15 is your remainder, and therefore x minus 5 is your slant asymptote. Okay, again, I strongly encourage you to find the slant from the simplified. To simplify first, but if you want to find it from the beginning, who am I to stop you? Nobody. I won't stop you. Is this helping or am I wasting our time? Is this helping us?
Definitely helps.
Okay. All right. Yes. Yeah. All right. So on the I'm not going to go through these with you. I'm leaving for you to practice, but it's just going over the rules for knowing if you have horizontal or slant. Okay. So just reiterating, if the degree of the numerator, I'm going to write it right here. If the degree of the numerator equals the degree of the denominator, you're going to have a horizontal asymptote, right? If the degree of the numerator is less than the degree of the denominator, you're going to have a horizontal asymptote, and it's going to be at y equals 0. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Yes? All right. I'm going to end our review. That is okay with y'all. The next part is going over limits. Do we need to review the limits? Because there was one other thing from the test, but I don't think that's the part we did bad on necessarily. Did we? No. All right. But this, yes. No, ask me. I'm here. Go. This one? You've already answered all the questions. You have your vertical, there's no horizontal, and you found your slant. No, you're good. Perfect. All right. So again, on here, you look at the original, pay attention to the degrees of the numerator and denominator, and you decide whether it's horizontal or no horizontal or a slant. Correct? Doable? All right. This is limit review. Do we need to review limits? Kind of not, or can we can? I'm asking, do we need to review? I mean, we have the stuff we should learn now, but. All right, just remembering from the limit, if I says x goes to negative infinity, this is all the way to the left. The limit as x goes to positive infinity, this is all the way to the right. This says limit as x goes to negative 3 from the left. From the left means that you are either approaching a whole or a vertical asymptote. Mhm. And since it's going negative infinity, that means I'm approaching a vertical asymptote. Okay, here, this time I'm coming from the right. And again, because I'm heading towards positive infinity, that lets me know it's a vertical asymptote. This time, the limit as x goes to 5. So from the left, I'm approaching a value. Do you see that? So this is from left. And because I'm approaching a value, that means this is a whole. Make sense? This is saying from the right. And again, I'm approaching a value. So this is a whole.
Are you saying the 3 is in 1? Why is it
The whole is going to be at 5, 3.
Mm.
And x equals 5 is undefined, simply tells us for sure that this is a whole. Okay, so based on what everything is doing, I now can state, oh, sorry. Because this is a number, this is a horizontal asymptote. Horizontal asymptote. So each limit tells me something about this graph. So the first two limits tell me that I have a horizontal asymptote at 2. So I know I have a horizontal asymptote at 2. Easy? Okay, and that's because as I'm going forever to the left and forever to the right, I'm just approaching 2, right? I'm not going anywhere else. I'm getting closer and closer to 2. Okay, the next thing tells me that I'm coming from the left and I'm coming from the right and I'm hitting something, but it's causing me to go opposite directions. What is that going to be? Vertical asymptote. So at -3, we have a vertical asymptote. Yes? All right, then the next piece is the whole. How do I know I have a whole? Because I'm approaching a number and there's a value. Does that make sense? So coming from the left and coming from the right of 5, I'm approaching what? 3, which is going to be a whole. So at 5, 3, I have a hole in my graph. So then just a sketch of this, doesn't have to be perfect, but my sketch would be making sure I go near the hole, continue out. On this side, I'm going forever to the left, and I'm gonna approach 2, never touch it. Going forever to the right on this side, and I'm heading towards negative infinity. And that's how you use the limits to create the graph. Please tell me that this helped y'all. It did? Okay. So now I will make the retest and put the retest out because we now have the tools to be successful on a retest, correct? Okay, yes,
What, grade you have to?
a 75.
What?
And the reason being is that if you did your review, how much is your review worth? So if you do your retest and you make up to a 75 on your retest, okay, so stop throwing a fit. Yeah. The math is there. All right.